What Eno didn't want to say is that programming languages are my substitute girlfriends. Yeah, it's easier to get a relationship with a programming language than with a But you have to take her kind of dating course. All right. Since I'm going to maybe insult some people, maybe I step on some toes. I just want to say, kind of, this is just my personal opinion, and also I want you to, to think about this, and then make your own decisions. Okay? All I want to do is make you think, and ultimately you decide for yourself. All right. Of course, you expect a talk where I'm going to kind of go and scream and kind of curse and talk about that Agile and Scrum are cancer that needs to be eliminated from this industry, right? That's what you all signed up for. You all kind of have your beers, your snacks ready. I have to say, this talk is not going to be like that. And what I want to do is I want to take you back to a little bit of some recent history. And in 2013, I left Microsoft. This was when Ballmer was still kind of in charge. Now he's doing some basketball team. I think that's way better for him. But I left Microsoft with the goal to make the world asynchronous and reactive. So I founded this small company, Applied Duality, that was trying to do that. And then in June, the first customer, one of the first customers I had was Facebook, where I worked with them on a language called Hack. Hack is a version of PHP that looks like PHP, but under the covers, it's really OCaml. Okay, Facebook is all written in Hack, but really it's written in OCaml with Hack syntax, with PHP syntax. So functional programming, if you're not doing functional programming yet, you're already behind. So who here is not doing functional programming? Okay, you can go home now. And maybe you can do some MOOC or start some course, but in a few years you will be obsolete. And then, slightly later that year, I started to work with Netflix on RxJava, and I guess that there's this thing has been a runaway success. I think a lot of people are using it. That has gone beyond my wildest dreams. Well, let's look at 2014. Well, at Microsoft, I did programming languages as a hobby, but it turned out that with my startup, it became, like a way to make money. So in April 2014, I worked with Google on Dart. And there I helped Dart to get also support for asynchronous programming, async await, and Dart already had support for streams, and now we put, or the API, an API for streams, and now we put that in the language as well. So Dart is one of the few languages that has kind of, complete support for synchronous, iterators, async await, and streams, all built in the language. So if you haven't looked at Dart yet, I would really say give it a try. Just like you should give Hack a try. And then in September 2014, I gave the Agile talk that you are all expecting to see, but that you don't get. But that talk was my interpretation of what I saw in Silicon Valley. I moved from the Pacific Northwest to Silicon Valley, and I worked with a lot of the internet companies there, and I was really impressed by the way they develop software. I was really impressed by the way that they look at software, and that's what I wrote down. And I will talk a lot more about this in the rest of the talk. And then in October last year, I did the FP 101X MOOC, where I tried to teach the world about functional programming. The MOOC starts again October 15, the second edition, so don't despair if you put up your hand and not doing functional programming, because there's your chance to learn functional programming. All right, and then disaster struck. On Christmas Eve 2014, my leg was swollen, my left leg was swollen when I put on my PJs. So I told my wife, I said, I don't trust this, you know, my leg is all swollen. So we went to the Stanford emergency room. And of course, you know, it's Christmas Eve, so you wait for a few hours. And then the doctors kind of, you know, talked to me and said, okay, it's okay, you know, probably you ate curry or some salt food, you can go home. So I went home and I went to bed. It was like around 4 a.m. in the morning. And then at 6 a.m. I got a phone call, and I still have that phone call right here on my saved messages in my voicemail box. And the doctor said, sir, when we did your blood test, the white blood cell counts were a little bit out of whack. And then I asked him, you know, what does that mean? And he was like, well, sir, if you want to have Christmas with your family, then it's okay, you can come in tomorrow. So I did a quick Google search, high white blood cell count, and that's not good, I can tell you. It's not good. Okay, so what I did, we took the car, went back to Stanford, and at 8 a.m. I was in the oncology section, and I was diagnosed with this thing called CML, chronic myelolytic leukemia. It sounds crazy, but actually, if you want to have some form of cancer, this is what you want to pick. This is really what you want to pick. So what happens, and this is the Cliff Notes version, what happens is that, you know, all our DNA kind of constantly gets kind of damaged, and then your body tries to repair it. And sometimes that repair can go wrong. And in this case, two parts of a chromosome kind of switch, and so they get glued back together in the wrong place. And again, this is Cliff Notes. I'm not a medical person, so if there's somebody here with medical background, they will probably laugh, but you know, just trying to explain this in computer science terms. So what happens, it's like, you know, fuzzing of your DNA. And what happens, you know, the DNA makes proteins, and now that this program is wrong, so they just switch two statements around, it creates a protein that your body doesn't recognize, and that kind of, you know, fucks everything up. Well, the nice thing about science is that they came up with a medication that binds to this particular protein. It's like an exception handler. It catches the exception, and that's it. So every day I take this pill. If I would have to pay it without insurance, I would be broke. So my life, I can now kind of, you know, count how expensive my life is. It's like a few $100s a day for this pill, but I'm happy that it exists. So as I said, that was that. But if that was the only story, life would be good, right? It's just, okay, you know, my DNA got messed up, I pop a pill every day, life goes on. But of course, being Erik Meijer, things are never simple in my life. And instead, a couple of things went wrong. So this was me around New Year's Eve. You know, I was close to dying, because what happened is that I got some internal bleedings, and one of the effects of leukemia is that your spleen, this is the thing when you're running, you know, you feel pain in your left side, that's your spleen. Your spleen gets enlarged, and when your spleen gets enlarged, it takes up all the space in your abdominal section, and so I got some bleedings for whatever reason. And since there was less space, the blood could not go anywhere, so my kidneys were kind of pushed out, I don't know, like 50 centimeters from where they were supposed to be. So I got, like, you know, I don't know what the doctors call it, acute kidney injury. And then they have to open me up. If you're curious, I can show you. I have like a big kind of, wound here, that everything that's soft in the belly, they kind of opened up to kind of go in there. I spent 5 days in intensive care. I was nearly dead. I could, if I have wanted, I could have just floated away and kind of, just given up. But I was fighting because, my journey wasn't over. I had to kind of, still eliminate Scrum and Agile from this world. So how, I mean, how could I die? All right? But anyway, it was pretty horrible, and I can tell you. So one of the things that happens to people when they are in the intensive care is they literally go crazy. There's a medical term for that, and I can understand that. It's a bizarre experience. I don't know if anybody here has ever been in intensive care. They probably know what I'm talking about. All right, so that was the end of 2014, not the kind of Christmas vacation I was expecting, but hey, I'm still here. So early January, I was released from the hospital because of the kidney moving around. All the nerves that kind of traveled to my leg were displaced and kind of, a little bit out of whack. So I couldn't walk anymore. My whole right leg was kind of, I couldn't move it. So I had to learn to walk again because I had a breathing tube in for a couple of days. I lost my voice. I couldn't even speak. I was like, so they kind of went in with a syringe and kind of injected kind of straight through my throat some stuff to kind of make it work. So all kind of fun things, the body it's kind of a remarkable machine. So that was fun. And then, of course, when something like that happens, you start to think about what is the meaning of life, what am I doing on this planet, blah, 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 blah. And it took me literally 6 months to get back to normal. And it was quite a big journey. But as I said, when something like this happens to you, you really start to think, what do I want to do with my life? And then in July, Mark Zuckerberg asked me about RX and how that could help solve, giving people that are on 2G a better experience, a better Facebook experience. Now you may have seen the kind of, the article by Mark Zuckerberg and Bono about giving everybody access to the internet. Well, that kind of, appealed to me because what I wanted to do is, like after this whole event, can I make my technology kind of do something for real people? Okay, so it's great to kind of talk about RX and kind of programming languages for other geeks, but what I wanted to do is really use what I do for normal people, for the world, to do good for the world. That's kind of what I came up with after I reflected about life. And when Mark Zuckerberg asked me that, I said, well, that sounds really good. That sounds like a nice combination of my technical stuff and a real opportunity to help people in the real world. You've seen what happened now with the refugees here in Europe. They use Facebook to kind of find their way. It's kind of amazing how this really affects normal people and kind of, improves their lives. And this is something, I think fits right in with the kind of new Erik. So just a few weeks ago, I joined Facebook, and that's what I'm going to do now. So my startup adventure was short but sweet. But thanks to this kind of big life-changing event, I think I can spend the few years that I might have on this planet, to really kind of help, the big population of this Earth. By the way, if there's questions in the end, I have a whole bunch of T-shirts here. So for people that ask questions, they will get a nice Facebook T-shirt. You see here, isn't that beautiful? All right. So as I said, if you look at why I made this decision, first of all. When I look at this, the Agile talk, that was, as I said, that was my learnings from working with many companies in Silicon Valley. And mostly that talk and that paper that I wrote about it, so there's an ACM, a CACM and an ACMQ paper about that. That talk was mostly inspired by Facebook, by the Facebook culture. And then, of course, the whole thing with RX, that was all done to kind of, make, communication at the cloud scale better. And then the last thing is, what I call here seize the day. Given that I can be garbage collected every single second, and all of you, you can be garbage collected every second. You cross the street, and you get hit by a car. So never take life for granted. I can tell you. So really, kind of, live every single second. That was the third thing. It's like, how can I help real people using my technical knowledge? And the great thing here is that, all these three things kind of just come together in a single spot. All right, so this is my new motto, to unite the earth, connect it, and that's what I'm going to be spending, the next couple of years on, and hopefully I will be able to, talk and give keynotes and talks many more times, and hopefully I can escape death a few years more. So let's talk a little bit now about the technical side and the opportunities about this, and then I kind of relate that again to this whole idea of how we should write software. So why did I get so enthused about push-based systems? So why did I do RX? Well, the whole point is that when you want to stay up to date about the state of the world, it's much better to push, not pull. So here is an example where there's me, and I want to kind of stay up to date about what Alice, Bob, and Carol are doing. But think about this, you can translate this into, that Erik is an app on your phone, and Alice, Bob, and Carol are sensors on your phone, right? Or, Carol's the UI, Bob is, the GPS, and, Alice is whatever. All right, so this kind of is a metaphor for whatever thing that has sensors in it or kind of, sources of information. Now, if you go and pull, well, I'm Erik, so I'm going to pull. So I'm first going to ask Alice. Alice, is there anything interesting that I should know? But, Alice is a little bit of a boring type, so she doesn't answer, or there's nothing. So, I ask her, and it's like, nothing happened. And then I ask Bob, hey, Bob. Bob doesn't answer. And if I'm not careful, I'm kind of blocked asking Bob until Bob answers, right? So this is why you have to do asynchrony, right? This is why you should never do a block and call, because Bob might not be there, or Bob might be slow, Bob might be kind of, grabbing a beer, and he doesn't answer. And then, of course, while I was kind of, busily kind of, pulling information from Alice and Bob, Carol had all kind of exciting things going on, but I never had the chance to ask her. So when I finally ask her, she says, you already missed all the action. It's now old stuff. All right? So when you want to stay up to date with the world, you have to push. You cannot pull. Another way to look at this is, say, in a very simple, naive implementation of pull. So if you're building a web page and you want to refresh the web page, what a lot of people do is they use set interval, and then they kind of pull the server at some rate, right? That's the way you do pull. Well, of course, there's the question marks here, because how often do you need to pull? You don't know. If we've seen with Alice, if you pull too fast, you waste resources because there's nothing interesting going on. And with Bob, we have seen that if you pull at the wrong moment, you get blocked, and then you don't know. So you have to. So this code here will never work. You have to always deal with the fact that you can get blocked. So you have to kind of do another layer of callbacks. But fortunately now JavaScript also has async await, or gets async await. I think Microsoft Edge is the first JavaScript thing that has async await, but of course if you use Dart you will get it also. But you cannot write code like this, right? Because otherwise you get blocked, or if you pull too slow, you might lose all the action, you might not go fast enough, okay? So you cannot, basically, when you pull, you never get it right. So here is the same example, but now where the sources push. All right, so think again, these sources can be sensors, or they can be your friends, or they can be stock ticks, whatever sources of information you can imagine. So in this case, Alice is kind of relaxed, she slowly, every once in a while, something interesting happens, but not that often. Bob, he is offline, but then suddenly he says, hey, I'm back from vacation. Okay, so you don't block, because Bob will tell you when he's back from vacation. I don't have to kind of check whether he's offline or online. Bob will tell me. And then, of course, now I hear all the interesting stuff that Carol has to say. She goes, and that she pushes really fast, and that's all fine. And then if Carol goes too quick, I can always put some code kind of right after her that kind of drops all her messages, or kind of, just kind of calms down the stream. That's much easier than going the other way around. So again, this is why I think things like reactive are so important, because in these cases, push works and pull does not work. Now, let's talk about scale, okay? Because here I had a very simple example with 3 sources. And if you look at your phone, I think the average phone has maybe 6 to 10 sensors. So there's, like a accelerometer, there's like a compass, there's GPS. There's a couple of sensors in the phone. But that's kind of a little bit. Now, if you look at things where, when we worked on RxJava, there the scale we looked at was about, I don't know, tens of millions of event sources. That's kind of, where RxJava was optimized for. But now, if you look at Facebook, recently, there were 1 billion people communicating over Facebook in a single day, okay? That's kind of, 1 billion, what is that? That is a 1 with 9 zeros, okay? So that's kind of quite different than, dealing with push-based systems on your phone. And this is also quite different than kind of, dealing with like a few million. And the other thing to notice is that, this is just 1 out of 7 people on the Earth, right? So this can be like more or less an order of a magnitude more. So if you want to build a system that works at that scale, it just blows my mind. Then the other thing that I just want to kind of emphasize is that it's really the mission of Facebook is really to kind of connect people. And so that's, again, it fits into my kind of, my new mission in life. But this thing is kind of what's scaring me, that's keeping me awake at night, is how, how is it possible to build software that can work at this scale? And just for the numbers here, if you look at RX Mobile, that was the thing that I was building with my startup. That only has to deal with like 10 of about 10 sensors that push stuff at you. For RX Java, we kind of assumed it would be 10, 15, 50 million, and now we have to go to 1 billion. And I'm kind of sweating when I think about that. Anyway, then the other thing is if you look at building software at that scale, and again, this is not only at Facebook, but all the companies I worked with in Silicon Valley and also at Microsoft, is the amount of moving parts is enormous. And this is one thing that I'm not sure that if you're in a small company that you can appreciate. But this is like numbers, these are kind of old numbers. But like, Facebook has open sourced about over 200 projects, okay? So these are 200 things that you need to know, more or less, in order to plug everything together. So this is one thing, is like I'm also part-time professor, and one thing that's really hard to teach to students when you when you teach them to program, you say, okay, let's do Java, right? We teach them to do Java, so you open up IntelliJ and you can public static void main and you start coding. That's not the way you code in the real world, right? In the real world, you get like whatever 200 different kind of technologies. And there's some bug, and then you go fix it. And you have to see how you can kind of, hook everything together. And honestly, I have no clue how we can teach this to students. I have no clue how I can even teach this to myself. I don't know how you guys deal with it, but I think this is something that I really would like to solve as well. So how can we kind of prepare students better for this kind of work? And the traditional way of teaching programming is not helping here. I think the only way that I know is Bertrand Meyer has a book where they try to kind of, they have like a simulation or something of the Paris metro system, and there they kind of dump you in the middle of the ocean and you have to kind of find your way back to the shore. But most textbooks about programming I think are completely outdated, have nothing to do with reality. So again, this is one of those things where I want to kind of apply my time on this planet to solve real problems, and that is, I think, teaching how to build software at this scale is one of those things. Now, here are a couple of these projects, and why am I talking about this? Well, probably you heard about React and React Native, so that's the kind of front-end stuff. Then there's Flow, which is a kind of, it's something like TypeScript, like it's a type system for JavaScript. Then there's a virtual machine. Then Infer is a way to do static analysis. There's Hexel, so they even do kind of different languages, including Haskell. Presto, that's the database stuff. And then there's many programming languages. Okay, so these are all examples of technologies that are used. Now the thing is, when you're building a push-based system, and that's one of the lessons that we learned at Netflix when we were applying RX Java there, is that you cannot block anywhere. So if you remember that picture I had where Alice, Bob, and Carol were pushing information, at some point, if you make a kind of a larger pipeline like this, and if anywhere things are blocking or not really push-based, then you might as well just kind of, then everything collapses. Because then it's the same as just doing traditional synchronous calls or pull-based calls. So really to make things work, to get one flow, you have to make everything push-based. You cannot kind of just have pull somewhere. And the thing is that most current languages and tools and APIs are all optimized for synchronous programming, okay? And that's why we need things like async await and so on to do async programming. But that's in the language. But now it also means that your APIs have to change, because everything that can be blocking should be eliminated from the APIs. And Microsoft, I think, did a good job when they introduced async await. They went through all of their APIs, and everything that took longer than X millisecond or could block, they made it async. But so it's not just the language; it's also the APIs. But then the tools. If you're doing callbacks, because basically that's what async is doing, now all your debuggers don't work anymore, because there's no sequential control flow, there's no call stack, so your debuggers are all messed up. So it keeps on going and going. So to make the world asynchronous is not just adding a few keywords to the programming language. It really means changing the complete stack from the UI all the way down to the database. And the nice thing is that for me, is that at Facebook they control the whole stack, which means that that there's at least a chance to get it right. And I'm sure that you've seen this diagram before. So these are what I call the 4 effects of programming. So if you look at the top left, so that's a synchronous call that returns a single result. That's what current programming languages have been optimized for since their inception, so for the last 50 years. But what we need to go async and push-based is we need to go down here. So we need to kind of have an asynchronous call that returns one result, and that's kind of getting more accepted now with async await in several languages except Java. Where's Brian Goods? Okay, Brian, Java is running behind. Okay, that's the only language. Even JavaScript has async await. Python has async await. Dart has async await. C# has async await. Even PHP has async await. But Java? No. We Java programmers, we kind of want to stay in the old world of synchronous calls. Or no, we have lambdas. We can do callbacks now. No. Callbacks are not good. Lambdas don't help you. So Java really need async await above anything else. I think you should drop everything for Java 9 and put in async await, and everybody would be happy. And if you know how to do that, Java people, you can read this paper here, where we kind of explain how to do this. We did it in Dart, and it comes with a nice denotational semantics to do that. But again, it's kind of super important to change that. We have to shake up the way we do programming to make this work. All right, so now let's go and talk a little bit about Agile. And let's talk a little bit about programming methodologies. So one of the things that I saw when I came to Silicon Valley that was completely different from what I see at conferences like this and what I see in Europe. I think Europe is much more into, for whatever reason, fell for Scrum and Agile. And the thing is that, if you look at Scrum and Agile, the way I kind of can phrase it is that if you look at McDonald's, all right, at McDonald's, every employee is a teenager, right? And in order to make a product that's kind of still of average quality with like low educated employees, you need a lot of process. You need a lot of steps to kind of make sure that what comes out in the end is presentable to the customer. That is, to me, what Scrum is about. So if you are like an average kind of whatever developer, you need a lot of process, you know, to kind of make something that's kind of okay. But that's not what we want to be, right? We are better than that. We are hackers. We are, you know, we know how to build this stuff. We don't need this process. So compare that with a Michelin star chef. If you're in a really good restaurant, the menu is different every day. The chef goes and sees, oh, they go to the market and say, oh, the fish looks really nice today. This cod, I will take that. Oh, and there's carrots, they look really good. And they just make things up on the fly, okay? There's no process, but the food is definitely much better. I'd rather go to a Michelin star restaurant than to a McDonald's. And I think it's the same with software. I'd rather have software that's built by hackers, by really good programmers, than some whatever average thing that's kind of, you know, has been built by doing stand-ups and, you know, Scrum Masters and whatever. Okay, so think about that. But I think the real thing about this is that it's scary for the managers. The managers feel that they are in control with Scrum, and that's why your boss pays you to go to a Scrum course. And your boss doesn't pay you to kind of, you know, spend some time and try something out new and kind of, you know, just kind of build stuff. Okay? That is the kind of the real thing. I think the essence of the hacking culture is here, is code wins arguments. The person that writes the code, because in the end, that's all what we're doing, right? We're building software. Software is code. Software is not words. Software is not UML diagrams. Software is not yellow stickies on the wall that you can move around. So the person that can move stickies around on the board is completely useless. The person that writes the code, that's the person that's useful. Okay, so every minute that you spend in a stand-up, every minute that you talk about code instead of writing code is lost. Okay, and that is the thing that, you know, I don't understand about Scrum and Agile, and it kind of, you know, makes you less than what you're capable of, because it treats you like a teenager in McDonald's. So don't fall for that. Okay, so. And just to compare this a little bit more, let me kind of show you the kind of, you know, the Facebook values. So these are kind of axioms. These are axioms that you, as a developer, use to kind of structure your day. Okay, so I want to write software. How do I kind of, you know, because there's so many things you can do. I think that's also one of the things with software. It's so soft that you can do everything with it. So you need some structure to make sure that you kind of stay on the right track. So let's go through these things here, and then I will compare that to Scrum. And then hopefully you will see the difference. Okay? So here's the number one thing. It's you focus on impact. So this is what I said too. It's like after this kind of tragic thing happened with my health, I thought, am I really focusing on impact? Am I really spending every single minute of my life achieving the most impact? And that's kind of, you know, I think what you do too when you write code. You should always kind of, you know, think about, do I solve the most important problems? So you look at this like, you know, am I just kind of, you know, messing around, or am I really trying to solve the right problems? And I think most people don't do this, and then you waste your time, okay? So you as a developer, it's your responsibility to always find and solve the most important problem for your company. And when you do that, I bet you nobody will complain that you didn't show up for that stand-up, because you fixed a real problem instead of talking about whatever imaginary problems. Okay. Here's the other thing. You have to move fast. And with move fast is the thing is that you need to learn. You cannot the only way you can learn about something is, and again, this is my personal opinion, you cannot learn about something by not writing code, by thinking about it. The only way you can really understand the problem you're working on is by actually writing code. For example, in language design, you can come up with the most beautiful design, but then it turns out that it's impossible to implement the type checker, or that it's impossible to kind of get good error messages, or that it's impossible to integrate this in the IDE. Okay, and the only way you can discover that is by trying things out. So you always have to be writing code. And then, you know, when you figure out that it doesn't work, then you kind of, you can do it differently. But this is the most important thing. And people, I think a lot of people are afraid of writing code, and then they go and kind of talk about it. They say, oh no, I first have to write my UML diagrams. Wrong. Just open the freaking editor and start coding. Okay, and that's related. So if you don't take any risks, you're not going to kind of, you're going to guarantee to fail. So, you have to try it. And sometimes it will fail, which is good. Now, of course, for most managers, the traditional managers, that's the thing they're most scared about, risk. Everything they do is to avoid risk. And I think that's also one of the big things in Scrum and Agile. It's all about managing risk. But I think this is completely the wrong way. You have to embrace risk, because if you don't do it, what it says here, the riskiest thing is to take no risks. But we have to not be afraid of that. Okay, then the other thing is openness. So this is, I think, one of the great things that the companies in Silicon Valley do. Is like Google has it, Facebook has it. Like once a week, the founders come and they have a meeting, and you can ask them anything. Okay, they treat you as adults instead of kind of keeping everything that's kind of important for you kind of hidden from you. So you have to be kind of the information, access to information is what you need, and that's not only for us developers, but it's for everybody. All right. I already talked about this. So given the time, I'm going to speed up a little bit. But again, think about yourself. Look at this, and see if this is something that you recognize yourself in. Okay? So, you see rules, and you think, what happens if I twist the rules a little bit? You have an API or you have a programming language, and can I kind of bend the rules to make the impossible happen? This is kind of, and I know, I'm pretty sure that every one of you here, when you do that at work, you kind of think that somebody told you this cannot be done in Java. But you found a way to do it. You feel absolutely proud. Okay? That's the hacker spirit. Okay, so you have to kind of challenge yourself intellectually. And this is what you don't like, right? You don't like stupid people, people with ties. Fortunately, I don't see a lot of people with ties here. Okay. You don't like boredom. But now look at this, okay? So now I've kind of briefly showed you all the kind of great things. Now look at this. Scrum, the art of doing twice the work in half the time. Okay, what does that mean? Twice the work in half the time, that means that you can do everything 4 times as fast. Okay, you believe that? It means that college, instead of 4 years, we can do it in 1 year. Right? Yes, we believe that. Okay, let's kind of all do college in 1 year. Elementary school. Okay, what is it? It's like, and high school, that's 12 years. We can do that now, divided by 4 in 3 years. So we can kind of compress high school and elementary school in 3 years, and university in 1. So in 4 years, we can take a kindergartner up to our level with Scrum. Let's do that. Let's introduce Scrum in education. And there are crazy people that are proposing to do Scrum in education because they believe that stuff. And then look at this. Look at this other stuff here. certified Scrum coach, Scrum masters, trainers, whatever. This is like a pyramid scheme. Okay, this has nothing to do with writing code. So talking about duality, okay, Scrum is the dual of hacking. That is, I think, it cannot be more different than the way you should. So look at Scrum and do everything completely the opposite. Then you have the right methodology. And so again, I've shown you these kind of, the rules here, the 5 rules of kind of, hacking. Now look at this. The Scrum is the opposite. I wasn't joking, because Scrum is all about prescription. Okay, it reads like a law. Okay, the product owner is the sole person responsible. Oh, there cannot be 2 persons responsible. There's only 1 person responsible. And if you don't do it, oh, the Scrum police will come after you. Okay, a sprint has to be like this. And if it's not like that, it's not a sprint. What else do we have? Oh, sprint planning. You can only do 8 hours of sprint planning. If you go like 1 minute over, you're not doing Scrum. If you're going 1 minute less, oh no. It says here, it's boxed to 8 hours. So be careful. Okay. And the daily Scrum is 15 minutes. Not more, not less. This is crazy, guys. Okay. This is like a boring. You need like a police, and you need like judges, and you like. And what happens in practice? I'm pretty sure when I gave this talk before, people say, "Well, but for us it works because we have our own version of Scrum." Of course, because it doesn't work. That is the proof that it doesn't work. But if you already have your own version of Scrum, why don't you throw it away altogether, okay, and go the hacker way? All right. As I said, don't be a McDonald's employee, be a hacker. Now, for managers, maybe you're scared, but what I tell you is that hackers are the ultimate employees. Okay, so don't be scared. These are the people that you want. If you're a manager, listen carefully. Hackers are the people that you want. Okay, and there's an interesting, I think it was meant as a joke, this link here, but it compares developers to bees and managers to beekeepers. Okay, but if you look at Scrum, managers are like sheep herders. Okay, but what managers should be is they should be like beekeepers. And bees are kind of, they are scary. They kind of go bzzz all around, and you have to kind of have your pipe and smoke to keep them away from not kind of biting you. But the great thing is they make honey, and you take away the honey, and they don't care because they make more honey. And that's what developers do. They write code, you ship the code, and they will write more code. You never have to be afraid that developers don't write code. The trick is that you have to kind of, keep them honest and focus on where is the most impact. And that's what, as a manager, that's your role. You have to be a beekeeper and make sure that they're producing the right honey and create all the right circumstances that they can be efficient in creating honey. And one of the things to do is that, you have to pay them a lot. And then, of course, there's another way, kind of, like one soundbite in which you can say that, is that you cannot herd racehorses, but you cannot raise sheep. So that's, and again, like Scrum is a way to try to make sheep kind of, into racehorses. Okay, so now I'm going to kind of, do a couple of more things here. Is that software is kind of, there's a lot of things that we can learn from the military here. And if you drop the last E from software, you get soft war. Now there's this very interesting document out on the internet. It's the Fleet Marine Force Manual 1 about warfighting. Okay, now I'm not a military person, but I think There's a lot we can learn from the way they kind of manage things and do things. They operate at incredible scale. They have been doing this for hundreds or thousands of years, so there's a lot of experience there. So it's always good to kind of look at that. And if you take this manual and you replace war by software, this thing is still true. It's amazing. It's amazing, right? Because here, look, software is complex. It's shaped by the human will. It's characterized by friction, uncertainty, fluidity. We all see this, right? This is when you write software. This is, how things go. Okay, and it's not an art. It's not a science. It's something that humans built. Now, if you then go and read further in that document, it also says the same thing what the other guy says about beekeeping. Command must be decentralized. Okay, so all the people on the floor should know what their mission is, but then in a situation of war, there's no way you can tell them, take 5 steps to the right, but only for 15 minutes, because otherwise you're not doing it right. That's not working. Okay, so I think this is a really good way to kind of look at this. If you want to manage software developers, you look at the military. And then the last thing here is that one of the things that hackers dislike is hierarchy, or people in suits telling them what to do because they have an impressive title or they kind of talk a little bit smoother. But that's something that you should fight against. Okay, it's only the code that speaks. So if somebody comes with some gut feeling, or it's like I'm the CEO, so you have to listen to me, don't do that. Okay, so vote with your feet. You can always take your laptop and leave. Okay, and I don't think that we do this enough as developers. We should take our laptops and leave. If you're forced to go and take Scrum training, you say, good, I'm going out for the day, I'm not coming back. Okay, and then the thing is, I say, either come to Silicon Valley, and I might be able to help you there, or we should have more companies like the companies in Silicon Valley in Europe. And I think we really, and I don't know what it is in Europe that this hacker way is not embraced so much, but I'm here to help you, and hopefully talks like this will inspire a few people and make the world a better place. On the other hand, you can also think, this guy was talking bullshit. I don't believe it. I love Scrum. That's great too. But make up your mind for yourself. Think about it. Don't take anything for granted. Don't just believe it because somebody told you so. Always be critical and always be hacking. Thank you very much.
Right, we don't actually have time, but I know the food won't be served until 8, so in your opinion, what is missing for the functional paradigm to revolutionize the industry?
Well, I think it already has, so there's nothing missing. If you look at JavaScript, JavaScript is really scheme with curly braces. So really the web is already powered by the lambda calculus. Even like I was joking about Java not having async await, but it has lambdas. So the world's most widely used language, which according to whatever the indexes that we have, is Java. It has lambdas. C++ has lambdas. So I think functional programming is there. Now, there's one thing, and maybe this is what the person that asked the question is thinking about. A lot of people think wrong about functional programming. They think functional programming means not using mutable state. I don't subscribe to that idea at all, because I cannot use mutable state in C. But then I'm not using functional programming. Functional programming is all about using higher order things, using functions, okay? And mutable state, that's not that important. But it has nothing to do with functional programming per se. And I wrote a paper about this. It's like, the curse of the excluded middle, because mutable state is just one of many effects. Exceptions, threads, reflection. There's so many effects, and you can simulate one effect in terms of the other. If I have threads and no mutable state, I can simulate mutable state, because I can make an object where I can send, get and set messages. And that object has no mutable state. It's like an Erlang kind of actor that maintains an immutable thing, but it's still now at the next level, it's mutable. So being immutable has nothing to do with functional programming. That's people that say that don't really get functional programming. So I think functional programming has already won, and this is this idea of using higher order concepts. Good. Are there any more questions?
There are a lot of questions, and I'll send them to them, and we don't have time to take them in public. So you can come up to Erik and get a T-shirt and ask a question.
You can get a T-shirt, and then we can. If you have more questions, I can, and I'm happy to talk to you. And thank you again. Thank you very much.